In topic 4, we're going to find summary statistics for grouped data. So grouped data, of course, are data that have classes or bins. We've talked about that in chapter 2. And then summary statistics, just as a reminder, are things like the mean, the median, the mode, right? Or measures of center, so mean, median, mode, but also the standard deviation, the range, the variance, all those good things, right? Those are the things we know so far for summary statistics. There are more, but those are the things we know so far. All right. Now, in studying behavior of Old Faithful, the Old Faithful geyser in Yellowstone National Park, geologists collect data for the time in minutes between eruptions. The table below summarizes actual data that were obtained. All right. So this is born out of a true example. This is Old Faithful. And so as my husband and I drove up to Old Faithful, we could see it stopping. So then we wanted to know how long we would have to wait for the next eruption. So we were curious to know about the time between eruptions. And we found that the National Park Service actually tracks that, and so do geologists because it's of interest to them. So they want to know how long you'd have to wait between eruptions. Now keep in mind, this is water, and so it is inside the rocks, if you will. There's a whole system down in here, and then it heats up and heats up and heats up because there's magma further down below, and then it comes shooting out, right? All right, so the time between eruptions, we have these classes. So these are the classes, these are the bins right here, but they're not really useful to us. I can't really go put them in to my calculator, for example, because the calculator won't know what to do, right? So if I try to go to stat, edit, and if I clear this out, right, and I try to type, hey, 42, 49, it thinks I want 40 minus 49, which is negative 9, which is not useful, right? That is not what I want. So I've got to find a way to represent that whole class. And that's where the midpoints come in, right? So your midpoints are the way that you're going to represent that class. So now remember, we've actually learned how to find the midpoints. We learned how to find midpoints in section 2.3. So you can go to those notes, right? So it's lower class limit, I'm just writing CL, plus the next lower class limit divided by 2. Whoop. So my 2 should be kind of more in the middle. All right, so that's the formula for finding the class midpoint. We learned it in section 2.3. So you're going to take 40 and 50, those two together. You're going to add them up and divide by 2. And you would get 45, right? So 45 is this midpoint. And then you can use the class width to find the rest of them. So you can see that we have a consistent width in this table that's 10. So we can just add 10, right? So class width, we can make a note, is 10, right? 10, 10, 10, right? Adding 10 gets you all the next numbers. So that means that I can just add 10 here. 45 is 55, 55 plus 10 is 65, and so on. That only works if you have a consistent class width, but we do. So I might as well write consistent here. If it's not consistent, you might have to do a little bit more work, a little bit more of that formula part from over here. So we found one using the formula, and then we used the class width to find the rest of them. And there we have it. All right, now let's think about what is the population here? Well, it's the waiting time between eruptions, right? And then we have a sample, and we can find the sample size, which is the waiting time between these eruptions. So we need to add these up. So let me go to the calculator. And quit. Remember, if ever you're in a screen you don't like, just press second and quit, second mode. So 8 plus 44 plus 23 plus 6 plus 107 gets us 200. Okay, so the sample and the sample size. So it was a random sample of eruption wait times, right? How long you had to wait between eruptions. I guess I could say between eruption wait times. There, I'll say wait times between eruptions. And the sample size is 200. And that was because this right here is 200, this sum of that frequency. It's technically 200 eruptions. Well, it's 200 wait times between eruptions. Let's put it that way. Okay. All right. Well, if that's the sample, what's the population? Well, that it would be the wait times between all eruptions of Old Faithful. Old Faithful, by the way, is not the most reliable. There is actually a more reliable one, Geyser at Yellowstone. So it's kind of funny that Old Faithful has this reputation as this faithful geyser that will always erupt, right on time. It's not true. There's another one that erupts more frequently and more steadily. Of course, that changes over time because these are geological features that have been there for, thousands and thousands and thousands of years. All right. So we're talking about Old Faithful. So I should say the wait times between all eruptions of Old Faithful, like ever. And then this is the random sample of wait times between eruptions of Old Faithful. All right. Now, what was the modal class? Okay, so mode is in there. See the mode as part of the modal class? So it's just saying what class was the mode, right? And we say that quickly by saying modal class. So we go back up here and we look for whichever one has the highest frequency. So 107 is the highest frequency, therefore the modal class is 80 to 89 minutes, right? There's our modal class. It's not the 107. The 107 is why it occurs, but the class itself is the 80 to 89. And if you want, you can say because 107 is the highest frequency, largest frequency. All right. Now, what about the time between eruptions? What type of variable is that? All right, so looking at these classes over here, these are the times that you have to wait between eruptions. All right, well, that's stopwatch time. Stopwatch time is always continuous because you can get more decimal places if you just have a better stopwatch, right? So as I watched the Old Faithful, collapse down as I drove up, well, actually, my husband was driving, then we can start a stopwatch and it can have tenths of decimal places, hundreds of decimal places, right? They do when you're in the Olympics and there's races going on, they get to the thousands of decimal places. So since it has more and more decimal places, it's quantitative continuous. All right, now what was the unit of measurement? Okay, the unit of measurement is right here. It's minutes. So you're having to wait in minutes. So that's our unit of measurement. All right, now we've done some preamble. This is all kind of chapter 1 and chapter 2 stuff that we were supposed to know. But now let's finally get to some chapter 3. Let's find the mean and the median. And I say by calculator, but what I really mean, that's kind of a typo. I really mean by technology. So I'm going to change that because you do not have to use a calculator per se. You can use StatCrunch. So I'm going to say technology down here as well. All right. Well, if you're going to use technology or, one way or another, you're going to need to put something in to that technology. So we're going to need a table. Oh, and just for the record, this is the actual video of us driving up to Old Faithful, so just in case you want to know. So I thought it was cute. They're buffalo. Those are little buffalo that are, well, big buffalo, actually, that were getting close to Old Faithful as it was about to erupt, which is where this problem comes from. It came from a real-life problem. All right, now if you're in StatCrunch, you actually have the ability to type the classes as they would have been. So we can say 40 to 49, 50 to 59, and so on, in a way that we cannot do when we're on the calculator. There I have it. but we still want the midpoints. So we're just going to write midpoints right here. And those would be 45, 55, 65. There we have it. And then over here we want the frequency. And I'll make this particular table available publicly so you can actually just go and type. I'm sorry, I had a little bit of issue with StatCrunch for a second there. So you can just type Math 133, Chapter 3, Old Faithful. If you just look up Old Faithful, I bet you'll find it. All right, so I'm going to, again, retype those midpoints. There they are. Then I go to Stat, Summary Stats. We have grouped or binned data. So our bins are in the midpoints. Our counts are in the frequency right there. And then we want to find, well, if looking ahead, we want the mean, we want the median. So I'm going to hold down my control button. We also want the standard deviation and the variance because it asks us for those in a question a couple away. So we might as well have them. And click compute. And there they are. Okay, so the mean is 74.85 and the median is 85. Now, if you're in the calculator, you would have to do the same thing. So let me type in the midpoints and frequencies 1 second. There it all is. Stat, calculate. Of course, you want to get your freq on. Leave your frequency list as L2 and calculate, enter, and there you can see the mean is 74.85. The standard deviation, which is S, is 14.7159. Right? Same as in with StatCrunch. Okay, so one way or another, we found those values. We found that the mean is 74.85, and the median was, oh, let's see if you remember. On the calculator, you have to kind of scroll down to see it. MED, there it is 85. Now the units for both of these, we already said, is minutes. So this is minutes, and the median is 85 minutes. There you have it. Found. And of course, we're using X bar because the data are a sample, which is going to be the answer down here. These are statistics. That's why I'm using X bar, right? Not mu. Right? Mu is a population parameter. So, and it's because these data were a sample. If we want to make notes for ourselves about how we came up with the values through StatCrunch or through the calculator, that's where you would write that, right? So in StatCrunch, for example, we entered the data, and then you use stat, then you go to summary stat, and you choose grouped or binned data, and away you go, right? So the midpoints were the bins, and the frequencies are the frequencies, right? The frequencies are the counts, right? So that's how to do it in StatCrunch. If you're doing it in the calculator, I'll write it down here because it's the same idea. You would enter the data, right, in L1 and L2. And then you would go to stat, calc, one variable stat, and you want to get your freq on. You have L1 equals the midpoints, and L2 is the frequency, right? You want to use as your frequency list. And then away you have it, okay? So the standard deviation, well, we just said they were statistics. So when you want statistics, and we run all that one variable stat stuff, just like we said with our frequency list on, the calculator gives us S and sigma. We want S because this was a sample, right? So we want 14.716. And it would be minutes. S squared, okay, the calculator doesn't give S squared. StatCrunch does. So StatCrunch, we can tell it's 216.560, right? On the calculator, what you have to do is notice the 14.716 and then type 14.716 and then hit the squared button to make that happen, right? So it's either way, it's 216.56, right? So you lose a little bit of decimal places if you use the calculator. StatCrunch is a bit more accurate because StatCrunch didn't have the rounding issue. Because when we're doing this in StatCrunch, of course, we rounded to 716. There were more decimal places there. But StatCrunch is keeping all those decimal places with the 216.560. Now, grant you could write or type more decimal places into the calculator if you so desired. That's up to you. Okay, so that would be minutes squared. So this is the standard deviation. Better label it because you won't remember. This is the variance. Okay, so standard deviation is S, variance is S squared. Now, why did I say approximate? So you'll notice right here I wrote the word approximate, and right here I wrote the word approximate. And so my question is, why am I writing approximate? Oh, and it was parts G and I. Sorry about that. G and I. I'll fix that typo. Why? Well, the calculations were based off of midpoints, right? So we've lost accuracy. Right? We are rounding, right? Calculations were based off of midpoints. So if you look at the table, you know you have 44 in this area, but you don't know where they are. Are they close to 50, close to 59? We don't know. We just chose 55. So we've rounded all of our data immensely by choosing those midpoints. We don't know what any of these values are. So it's 6 what? 670s, 672s? Was it 170, 171, 172? We don't know. So we chose 75 to represent that group, but that might not be a fair representation. So by using midpoints, we very much have rounded our data a lot. And so that means that every answer we come up with is approximate. All right, now what about the interpretation? Okay, well, there's a script for that we learned. So we want to keep in mind that script. See script from section 3.2. And I went and grabbed it. We expect, and then we write the variable in context. So in our case, it's the wait times between eruptions of Old Faithful to be blah, blah, blah minutes, give or take blah, blah, blah minutes, right? The hard part on these ones, honestly, is this piece, right? Because you really have to know what you're saying and what you're talking about. That's where, the difference is from problem to problem. So we expect the wait time between random eruptions of Old Faithful, right? So that's all that context. The lovely geyser in Yellowstone National Park. So this right here is your context. And we expect it to be, well, let's see, the mean was 74.85 minutes, give or take. And I'm just going to round this a little bit. I'll say like 14.72. So that way they at least have the same number of decimal places. Now let's think about that for a second. If I grab a calculator, what's 74.85 plus or minus 14.72? Okay, 74.85 minus 14.72 is 60.13. 74.85 plus 14.72 is 89.57. So this would be, if I make a little window for it just for my own benefit, 60.13 to 89.57. So that's another way we can interpret this, is we could say, hey, most wait times, actually I'll do it in green here. between eruptions of Old Faithful. Oops, Old Faithful, there we go. Fall between 60.13 minutes to 89.57 minutes. That's a little arrow for 2. Which is actually what happened to us when we got there. The park ranger was like, about an hour to an hour and a half, right? Hour and a half. So he was in his little outfit, and that's what he told us, that we were going to have to wait about an hour. So we got a very good seat for it, as you can see from that video. So it was very nice. We watched the buffalo kind of roam around while we waited for the eruption. All right. So what do you notice about the distribution that should be mentioned in discussing the geyser eruptions? Well, there's something else to kind of notice. It's really peaky, right? There's a peak right here at 50.59. So you're really going to wait just a little bit less than an hour, or you're going to wait about an hour and a half. So it takes a while for that water to kind of get enough heat, get enough energy that is just going to blow out, right? So it has to gain the heat from the magma down below. Well, it's indirectly from the magma, but it's not touching magma, right? So you're either going to wait this long or you're going to wait that long. It's really bimodal, right? You can see you don't really wait very often 40 to 49 or 90 to 99. That's unusual. Well, maybe that's strictly unusual, but it was rarer, right? So this distribution is bimodal. It's also skewed left. I don't know if you noticed. You can see the peak at 107. And there's like a tail going down to the low side. So it's skewed left. You can also see that it's skewed left because the mean is less than the median. So there's two things. Skewed left, right? The mean is less than the median. This was 74.85. This is 85, right? So the mean is significantly less than the median. You can also see it from the table. Whoop. Also, like that. It's also a little bit bimodal. I mean, I grant you that the 80 to 89 really is a big peak, right? So there's 80 to 89, which was a frequency of 107, but there was also 50 to 59, which had a frequency of 44. And really, they were the two big hitters. Those are the most likely wait times, being practical. Which is why the park ranger said, oh, you're probably going to wait around an hour, or you're going to wait an hour and a half.